So let's get to the meat of this, which is converting between degrees and radians, right? If you are an American who uses feet and you are going to be working with a European who uses meters, one of you is going to have to convert your units into the other unit in order to be able to have a conversation. So we're going to do that. Sometimes a problem will give you a angle in degrees, and it will be advantageous for you to change it into radians before working with it, or vice versa. So we said that a whole circle is 360 degrees, right? But we also know that a whole circle, well, we just came up with how many radians there are in a circle. There's 2 pi of them. I'm going to use RAD for radians, just like your calculator. So it shouldn't be too big of a leap to see that 360 degrees and 2 pi radians are the same value, right? They're both a complete circle. So we can say that 360 degrees equals 2 pi radians. Yeah? Dividing both sides by 2, we can say that pi radians equals 180 degrees, and that's going to be our unit conversion. Okay, that's going to be our conversion factor. That's how we're going to get from degrees to radians and from radians back to degrees. For example, convert 150 degrees to radians. Okay, well, it's been a while since many of you have done unit conversion, but let's go ahead and give it a shot. We've got 150 degrees, and we're going to multiply that by some fraction that doesn't actually change the value of things, right? We did this earlier this year. We know that there are pi radians in 180 degrees. This fraction here that I just made is actually equal to 1 because those are 2 equivalent values, right? Pi radians and 180 degrees are the same value, so their quotient is 1. So we're not actually changing the value, we're just changing the units. Now, I put the radians on top and the degrees on the bottom because now I've got degrees on top, degrees on the bottom, so the degrees cancel, and I'm left with 150 pi divided by 180. Okay, well, those are both divisible by 10, so I get 15 pi over 18. 15 and 8 are both divisible by 3, so I get 15 divided by 3 is 5, and 18 divided by 3 is 6, so I get 5 pi over 6 as my final answer. 150 degrees is equivalent to 5 pi over 6 radians. Again, I know it seems weird to get pi involved, but once you start solving for arc length, the pi's tend to cancel out. Not always, but they tend to cancel out. All right, let's do another example. Example 2. Convert 3 pi over 4 radians to degrees. Okay, well, I can think of 2 ways of doing this. I will show you both. Okay? Since there is a pi in here, there isn't always going to be a pi in here, but because there is a pi, we know that pi radians is equal to 180 degrees. We can just do a substitution. We can say that this is 3 times 180 degrees over 4, and then we can go from there. Okay? So anytime you're converting radians to degrees, if there is a pi in the radians, you can just take out the pi and substitute in 180 degrees. That will work. But I'm going to go ahead and do this the proportions way. Anyway, so we have 3 pi over 4 radians. Remember, radians are on the top of that fraction, right? So again, we're going to multiply by our scale factor, but since we have radians on the top, instead of instead of pi over 180, we're going to put the degrees on the top and the pi radians on the bottom, right? Because now the radians on the top and the radians on the bottom cancel, and we are left with degrees. Okay? And hey, look, conveniently enough, the pi also cancels, just like I said it probably would. So the pi goes away, and we're left with 3 times 180 divided by 4. Well, I happen to know that 180 divided by 4 is 45, times 3 is 120, 135 degrees. So that's the basics of radians. Now, I will release a couple more videos getting more into depth about this. If you are confused about what radians are and where the hell pi came from and why we're doing all of this, that's okay. I have more videos coming that will explain more, but this video was intended to be a very, very quick, very surface level look at what radians are, where they come from, and why they're useful. So if you're still having a hard time, just look forward to the next video. Ask questions that you've got down in the comment bit, or you can email them to me, or you can put them on Google Classroom. I hope this went well. I hope you're doing well. Happy Monday, and I will see you next time.